Faster than the fabric of spacetime can keep up with it, and it'll just rip, and I'm terrified by this since the launch of the James Webb Space Telescope. It has sent back numerous groundbreaking discoveries to Earth, but its latest revelation is undeniably the most alarming in the past decade. This powerful telescope has just confirmed the imminent explosion of Polaris, the North Star. Polaris, long hailed as the focal point of the night sky due to its unique position, is now on the brink of a catastrophic supernova explosion. What is the gravity of this threat and how will it affect our night sky and astronomical measurements within our solar system? Join us as we explore the terrifying images captured by the James Webb Space Telescope and how the Polaris supernova will dominate the night sky worldwide on February 15, 2013. A mysterious explosion rocked the urban Russian city of Chelyabinsk in 2013. The blast resulted from the entry of a massive fireball, approximately 17 to 20 meters in size, into Earth's atmosphere. This destructive meteor hurtled through the atmosphere at a staggering speed of around 19 kilometers per second. Surprisingly, the energy released by this colossal fireball was equivalent to 30 times the energy of the Hiroshima atomic bomb. The explosion's shockwave shattered windows, caused damage to buildings, and left over 1,500 people injured, primarily due to flying glass. The sonic boom generated by the explosion was unlike anything anyone in that part of the world had ever experienced. Just the sound alone resulted in significant structural damage to buildings in the region. Fast forward to the present day, and the James Webb Space Telescope has detected something even more catastrophic hurtling toward Earth, leaving scientists deeply concerned about our level of preparedness. The Polaris supernova, once considered a baseless doomsday prophecy, has now been confirmed by the James Webb Space Telescope to be much closer than previously imagined. A recent research paper presented by the esteemed Royal Astronomical Society in September 2023 has cast a shadow of uncertainty over the fate of this celestial luminary. Keep watching as we delve into why experts firmly believe that the Polaris supernova will dominate the night sky worldwide. But before we delve into the captivating details, let's take a look at the star in question. Polaris, also known as the North Star or Pole Star, occupies a remarkable position in the night sky due to its close proximity to the celestial North Pole. Positioned almost directly above Earth's North Pole, it remains almost stationary, creating the illusion of a fixed point in the northern sky. Found within the constellation Ursa Minor, or the Little Dipper, Polaris shines with moderate brightness. It boasts the size of a yellow-white supergiant star, significantly larger and brighter than our own Sunday. However, it is situated at a much greater distance, estimated to have a radius about 40 times that of the Sun. Despite its perception as a solitary star to the naked eye, Polaris is, in fact, part of a complex triple-star system. The primary component, known as Polaris A, is a yellow supergiant. It orbits a smaller companion star referred to as Polaris AB, while this pair also orbits a third star called Polaris B. The gravitational interactions among these stars shape their orbits and influence their behaviors. These intricate dynamics impact the luminosity and characteristics of the stars involved. Any disturbances in these interactions can result in irregular variations in the star's brightness or pulsation patterns. However, the precise mechanisms and complexities of these interactions are yet to be fully understood. Given Polaris's distance from Earth, approximately 323 light-years away, the light we currently receive from the star actually originated 323 years ago. This means that if Polaris were to explode today, we would be unaware of the event until 323 years from now. By the time we witnessed the explosion's light from Earth, it would have already occurred over 3 centuries in the past. It's important to note that these predictions are based on empirical evidence observed in the present. Therefore, it's plausible that Polaris may have already exploded, and we simply haven't yet observed the light from that event. Throughout history, the North Star or Polaris has held significant cultural, navigational, and symbolic value across various civilizations and eras. Its stable and fixed position near the celestial North Pole made it an invaluable navigational aid for ancient mariners and travelers. Polaris holds great significance in Norse mythology, where it is believed to be the star known as Lodestar or Hin. The Vikings relied on Polaris as their guiding light during their daring voyages across the seas, helping them navigate their ships and discover new lands. In a different context, Polaris played a crucial role during the 19th century in guiding escaped slaves along the Underground Railroad in the United States. Urban legend says escaped slaves would follow Polaris to guide them northward toward the free states of Illinois, Indiana, Ohio, or to Canada. Polaris served as a powerful symbol of hope and liberation, guiding enslaved individuals to freedom as they made their perilous journey northward. Polaris's unwavering presence in the night sky provided a constant beacon of light and direction, leading them to safety. Its alignment with Earth's axis made it a reliable reference point for determining direction, particularly in the Northern Hemisphere. Polaris carries symbolic importance in different cultures, representing constancy and steadfastness. It stands as a pole star that remains fixed amid the celestial dance of the night sky. In myths and folklore, it is often symbolized as guidance, stability, or a celestial anchor. Polaris also played a crucial role in astronomy. Its fixed position served as a reference for observing other celestial bodies, facilitating the study of celestial motions and patterns. As a variable star, Polaris exhibits periodic variations in brightness. This unique characteristic has helped uncover significant discoveries about stellar properties and the nature of variable stars. Additionally, it has proven vital in determining cosmic distances and calibrating instruments. These pulsations typically follow a predictable pattern, allowing for easy prediction. However, recently, Polaris has deviated from this expected behavior. The irregularities in Polaris's pulsation cycle have puzzled astronomers, prompting a closer examination of this celestial anomaly. Instead of adhering to a predictable pulsation pattern, Polaris has started displaying an erratic and unpredictable cycle of dimming and brightening. Scientists have voiced concerns that the star may be approaching its end, as this behavior aligns with patterns observed when a star nears the conclusion of its life. The elongation of Polaris's pulsation period, which traditionally exhibited stable cyclic dimming and brightening, can be attributed to the interactions within the star system. From our observations, we can note an annual increase in the pulsation duration of approximately 45 seconds. While this may seem insignificant, it holds significant implications. Some astronomers suggest that these fluctuations in Polaris's atmospheric conditions, directly impacting its pulsation patterns, may be induced by the gravitational interplay among the Polaris stars. The star's irregular pulsation patterns continue to raise questions and speculation among astronomers, suggesting the possibility of an impending end or significant changes in its behavior. But before we explore why the Polaris supernova will have a devastating impact on the night sky all over the world, let's understand if the data from the James Webb Telescope have been observed before. Has such a terrifying star explosion happened in modern history, and how is this similar to the Betelgeuse supernova? The James Webb Space Telescope stands as the largest and most advanced space telescope ever constructed. Its primary purpose is to take humanity on an extraordinary journey back to the origins of the universe. With its cutting-edge technology, the JWST possesses a remarkable ability to look back in time, capturing cosmic events that occurred billions of years ago. It's like a superpowered cousin to the Hubble Space Telescope and was designed to unravel the secrets of deep space. With a massive segmented mirror about 6 times larger than Hubble's, it can capture light from unimaginably distant galaxies. And get this, it's designed to observe the universe in the infrared range, allowing it to peer through cosmic dust clouds and witness the birth of stars and galaxies. However, scientists were astounded by a recent revelation concerning Polaris. Following the discovery made by the JWST of irregular pulsation patterns exhibited by the star, alarming images were transmitted back to Earth, suggesting that Polaris is on the brink of a catastrophic explosion. In response to this alarming finding, scientists embarked on a quest to identify similar patterns in previous stars. And it turns out that this is not the first time a star has exhibited such irregularities. Betelgeuse, a prominent star in the Orion constellation, shares striking similarities with Polaris in terms of its unpredictable luminosity. The fluctuations observed in the brightness and patterns of both stars are remarkably similar, leading experts to draw intriguing parallels between their behaviors. Seed stars like Polaris and Betelgeuse go through various stages in their life cycles. These celestial entities pulsate regularly for eons, but undergo peculiar changes in their luminosity as they approach the end of their stellar journeys. NASA has been particularly captivated by the anomalies exhibited by Betelgeuse and has raised concerns about a potential explosion. In contrast, similar scrutiny and official announcements are now focused on Polaris following the findings of the JWST. Regarding Polaris, definitive announcements have yet to be made. However, based on Polaris's irregular pulsations, scientists speculate that the star has entered the stages of helium depletion, which are commonly observed in seed stars nearing the end of their lives. As a seed star exhausts its stable helium supply, it undergoes erratic pulsations, resulting in fluctuations in brightness. This depletion triggers a series of events leading to irregular light emissions, potentially reflecting the depletion process occurring within Polaris. Nevertheless, it is important to note that while these irregularities align with behaviors indicative of seed stars in their twilight phases, definitive indications of Polaris nearing the ultimate stage of its life cycle remain inconclusive. Astronomers continue to analyze and interpret these irregularities in their quest to understand the fate that awaits Polaris. If Polaris were to go supernova, it would be a spectacular event visible in our sky. The star would suddenly become incredibly bright, potentially surpassing the moon in luminosity and becoming one of the brightest objects in the night sky. This dazzling display could last for days, weeks, or even months. The appearance of the star might change dramatically, transforming into a brilliant point of light or a transient object with colorful hues, before eventually fading away. Such an event could temporarily alter our perception of the familiar pattern of the Big Dipper or Ursa Minor, as Polaris currently serves as the North Star and is part of these constellations. However, rest assured that despite the spectacle, we would be perfectly safe. Considering the mass and distance of Polaris, even if the star were to explode, Earth would likely remain unaffected. While a Polaris explosion may not be as visually striking as that of Betelgeuse, it could still be visible to the naked eye for an extended period and outshine nearby stars. The astronomical community and stargazers worldwide would undoubtedly be captivated by such an event. Astronomers and observatories would closely observe and study the phenomenon, adding to our understanding of stellar evolution. However, the specific visibility and impact on Earth's atmosphere or surroundings would be less significant compared to a supernova event that occurs closer to our planet. The fate of giant stars is often marked by a spectacular event known as a supernova. However, in the case of Polaris, the North Star, it is expected to be quite different. Unlike most massive stars that end their lives in a supernova explosion, Polaris is not likely to go out with such a cosmic bang. Supernovae are typically the explosive grand finale of massive stars, where a colossal eruption rips through the star, dispersing heavy elements and sometimes giving rise to neutron stars or black holes. However, Polaris is unlikely to follow this well-trodden path. When a massive star consumes all its nuclear fuel, it reaches a critical point where it can no longer withstand the crushing force of its own gravity. This leads to a catastrophic collapse of the star's core, triggering an intense shock wave that races outward, culminating in a violent explosion. These stellar explosions, known as supernovae, are broadly classified into two types, Type 1 and Type 2. Type 1 supernovae are more common and occur in massive stars with complex internal structures. When the core of such a star collapses, the outer layers are explosively expelled, creating a brilliant burst of light and energy that can be observed from immense distances. On the other hand, Type 2 supernovae take place in binary star systems where one of the stars is a white dwarf. In the case of a Type 2 supernova, a possible scenario involves a companion star expanding and ejecting material into the orbit of the white dwarf. As the white dwarf accretes mass from its companion, it eventually reaches a critical threshold, approximately 1.4 times the mass of our Sun, where a nuclear fusion reaction is triggered. This sudden release of energy results in a catastrophic explosion. Another scenario involves the merger of two white dwarfs in a binary system, their combined mass surpassing the critical limit and initiating a runaway fusion reaction that leads to a supernova. Thanks for watching another episode of InfoPaper. While you're still here, click on the other videos you see on your screen right now.